20 plus 4-pin motherboard connector. The 24-pin ATX motherboard connector is the primary power artery of a modern computer. It provides the essential voltages needed to wake up the motherboard and manage the distribution of power to every other component. While earlier systems used a 20-pin connector, modern hardware requires the extra 4 pins to provide additional current for high-performance features like PCI Express lanes. The evolution of the 20 plus 4 design. The term 20 plus 4 refers to the physical design of the plug. It consists of a main 20-pin block and a smaller detachable 4-pin block. This clever design was created to ensure backward compatibility during the transition from the older ATX version 1 standard to the modern version 2 standard. If you are a technician working on a very old motherboard that only has 20 holes, you can simply slide the extra 4 pins away and plug in the main block. However, on any modern motherboard, you must snap the 2 pieces together to form a solid 24-pin block. The extra pins provide additional 12-volt, 5-volt, and 3.3-volt lines to ensure the motherboard doesn't overheat or starve for power during heavy workloads. Critical control signals, the green and purple wires. While most of the pins on the connector provide the standard power rails we have already discussed, there are 2 specialized pins that are vital for a technician to understand. The first is the power on signal, which is almost always a single green wire. When you press the power button on your computer case, the motherboard pulls this green wire to ground, which tells the power supply to wake up and start sending electricity to the rest of the system. If you are troubleshooting a computer that won't turn on at all, you can perform a paperclip test by bridging the green wire pin to a black ground pin to see if the power supply fan starts spinning. The second is the 5-volt standby signal, which is the purple wire. This pin is always active as long as the power supply is plugged into the wall, even if the computer is turned off. It provides a tiny amount of power to the motherboard so it can listen for a power button press, a wake on LAN signal, or a scheduled alarm. As a safety rule, you should never touch internal components while the purple wire is active. Always flip the physical switch on the back of the power supply first. Troubleshooting and installation tips. When installing the 24-pin connector, it requires a significant amount of downward pressure. It features a large plastic locking tab on one side that must click over a ridge on the motherboard socket. If this tab is not fully engaged, the connection can be loose, leading to random restarts or a computer that suddenly loses power when bumped. One common mistake for beginners is confusing the extra 4-pin block of the motherboard connector with the 4-pin CPU power connector. You can distinguish them because the pins on the 24-pin block are keyed with specific square and rounded shapes that will only fit into the main motherboard socket. Never force a connector if it doesn't slide in smoothly, as the keying is designed to prevent you from sending the wrong voltage to a delicate circuit. The importance of the power good signal. Finally, there is a gray wire known as the power good signal. After you turn the computer on, the power supply performs an internal self-test to make sure all the voltages are stable. Once everything is safe, it sends a 5-volt signal down this gray wire to the CPU. If the processor doesn't receive this all-clear signal, it will refuse to start to protect itself from dirty power. If a computer turns on and fans spin, but it never reaches the BIOS screen, a failing power good signal is a prime suspect.